Right now I'm going to go and put this on full screen. Okay, and now I'm going to start in a few seconds.
Okay.
Oh, hold on. I forgot one thing. I don't know if you're familiar with this. For Google Hangouts, okay, I'm in control, so that's correct. But person who's in control I haven't shared screen, that would probably help. Wow.
Okay.
There we go. Yep, see how it does that?
Yeah, that's awesome.
Okay, so now, and I'm selected, so it's showing what I'm doing. There we go. Okay, now
wonderful.
Hello, CIT 260, and welcome to Inside the Sphinx's Island. My name is Sarah Brote-Akula, and I will be joined by my partner, Eldon Chandler, and we are going to walk you through our game, The Sphinx's Island. First, I'm going to talk to you about some selection statements. Our first example is a switch statement from our main menu view. Now, a switch statement works by giving the user several options from which they can choose. In our case, we have options from our game's main menu. First option is N, which starts a new game. The second option is G, which starts a saved game. The third option is H, which displays the help menu. The fourth option is S, which saves the game. And the final option is E, which exits out from the main menu and shuts down the program entirely. How a switch statement works is that if any of these are not selected, it automatically defaults to the print line statement at the bottom, which tells the user that they have made an invalid selection and they need to try again. The way that we have coded our switch statement is so that the user can input either the uppercase or the lowercase version of any of these selections for the menu items. This makes it a lot easier for them, so they don't have to make sure that they enter it exactly as they read it. For instance, they don't have to enter just an uppercase N to start a new game. However, if they tried to enter, for instance, an X, they would automatically get an invalid selection because it does not fit into any of the case categories outlined in the switch statement. Our next selection statement is an if statement, and this is from one of the riddles in our game. In our game, the user goes through the game and encounters 3 sphinxes and has to solve a riddle from each sphinx to get off the Sphinx's island. And in this case, this is the first riddle that they would have to solve. We did a simple y equals mx plus b calculation, which is, if you remember from math class, slope. So with an if statement, you would have sort of a break point after each of these if statements. And if at any point the input does not turn out as valid, it would stop the function completely, return the invalid statement. In our case, it is negative 999, and automatically stop the function from fulfilling itself. However, if the input is valid, it would continue on to the next if statement and go on throughout the function all the way down to return and finish the function. So for instance, if you're looking at our slope variable, our parameters are anything that is between 0 and 10. Obviously, if we're talking about real math, it could be any number, but for the sake of simplicity, we decided to set our boundaries as 0 and 10. So let's say I entered in 3. It would move on to the next if statement because that is between 0 and 10. However, if I had entered in 11, that would be without those boundaries, and it would automatically stop the function, return negative 999, and not move on to the next if statement. Now I'm going to hand this over to Eldon, and he is going to talk to you about our next selection statement.
Hello. Our next statement is the if-else selection statement. And much like the if statement, it's much like that. However, the difference really is in there being a condition and there being a true action and a false action. It adds a false action um, in comparison. So the if statement just has a true action, but the if else has a false action. And the example that we have here that Sarah and I did is that it matches, our code currently does not have an if-else statement, so we created one. And so what we're showing here is just simply trying to show if a score, a student's score is greater than or equal to a 71, then they have passed. The pass-fail variable equals passed. The false to that is in the else, which says it's failed. And so, as we can see, the score variable up at the top is 81. That will be evaluated by the if statement, and since that is false, because it is true, it will be evaluated to true, and the pass-fail is passed. If it was below 71, so if it's 70 or lower, then it would evaluate to false. And as we see, the value is passed to the, oh dear, this is the old code that before I fixed it. What we see in the print to the console should say you have concatenate pass-fail variable concatenate period. So that's how that else if works. And I am ready to move to the next slide, Sarah, if you would move that. Thank you. So the else if, the if else if statement is a little bit different in that it's looking for two actions that exist, and each action is based on a different condition. Or maybe an easier way for me to understand this is to say that when there are multiple conditions and each condition has a different action. And so from our code that we wrote together in our game, we have this condition. So we see if the number of Sphinx is equal to 3, then the true evaluation on that is to print to the console, congratulations, you have outwitted all the Sphinxes on the Sphinx Island. And then else if that above statement is not true, then it moves to this else if where it equals 2, and so on until you get to the bottom there. And of course that so it ends. So you have your if, your else ifs, as many else ifs as you need, and then it goes to a final else, and then that's the end of that select statement. Okay, we are ready for the next slide. So most of the remainder of our slides are going to be based around these 7 steps of the function design. And so this is just to show that here are the 7 steps, and we will be going over these 7 steps in the most of the remainder of our slides. And I'm ready for us to go to the next slide. What we have here is one of the unit tests that I had created in an individual assignment. And so one of our Sphinx riddles, it's a calculation that the Sphinx gives the player. And the player is to input 3 variables, so 3 numbers. And then it gives a calculated sum. So in our test matrix, a valid inputs, you see valid input 1 is a value of 3, and then we have a input 2 is a numerical 4, input 3 is the numerical 2. And then the calculation, the calculated sum of that is a 5, because 3 plus 4 minus 2 equals 5. Following along with that, in the invalid, we defined that invalids will return a negative 999, because that to us is just more easily identified as an error. So that's why we have the negative 999 as the error output. As we can see from our pseudocode, that we are defining the boundaries from the test matrix and from the pseudocode, really, that we can see that we have these boundaries of 0 and 100. So we're saying here that input 1 needs to be within 0 and 100. So it can't be less than 0, and it cannot be greater than 100. Just for simplicity's sake, again, for this program, and returning a negative 999 if all of those conditions are not true. And then each of those conditions, 1, 2, and 3, need to be within those bounds of 0 and 100. The next condition we're going to look at is to see if input 3 is greater than the sum of input 1 and 2. And that way we're not returning a negative number. We decided we are going to keep all of our variables in as a positive number. And then you simply see the calculation. And I believe we are ready to hit the next slide. Thank you. So this is the code that I wrote, derived from what we are just looking at from doing the pseudocode, doing the test matrix, and playing computer, testing the logic of our code. So what we're saying here again is if any of the inputs are outside of those bounds of 0 and 100, then we have an error. Once that has been evaluated, then we're saying the sum of input 3 needs to be less than the sum of input 1 and 2, and that returns an error if that condition is not true. If those conditions if we've met the conditions, then we're doing the calculation. And we are ready to move to the next slide, Sarah. So thank you.
All right. So now I'm going to take you through those same 7 steps for a function that I wrote. And this is actually the final riddle for the final Sphinx that the player will face on the island. And this is another mathematical equation. It is a very simple one. It's one that you use to calculate the diameter of a sphere. So first we are going to define the problem, and as I said, it is this sphere diameter calculation. It is 4/3 pi r cubed. Now we're going to create a test matrix. This is a very simple test matrix because there's only one input, and that is the variable sphere diameter. So first we have our valid column, in which I have used 4. And that yields us a radius of 2 and a radius cubed of 8. And I did not include the final output of that because you'll see that in the next section where we play computer. We also have the invalid section, and again, for the simplicity sake, we decided to keep this within the boundaries of 0 and 10, even though mathematically speaking, of course, those numbers could be different. And so some negative numbers such as -1 and -4, and then also a number that was outside the upper limits of that boundary, 11. And all of those returned -999, which, as Eldon previously established, is our number that that designates an invalid response. The final section of the test matrix is the boundary section that again just sort of tests and delineates the edges of the boundary that we are going to be using for this particular input, which again is 0 and 10. And you'll see that any input of 0 yields 0 because there is multiplication involved in this particular equation. And 10 yields a valid output, which is good to see. So next we would move on to outlining the solution and writing it in pseudocode. And this is a simple if statement. If the sphere diameter is between 0 and 10, then you move on to the rest of the equation and you fulfill that and you return the statement and the function. However, if it is without those bounds, if it's a negative number or if it's greater than 10, then the function stops and it returns the invalid statement of negative 999, and you don't get to progress any farther. Next, we get to play computer, and we run through each of the inputs outlined in our test matrix, and we go through and we do the math for each of them. And as you can see in our table, the memory bank test, how each of that plays out. So our valid input gives us a perfectly reasonable answer, and we are able to see that it works. Our invalid inputs, it stops. It tells us that this is not within the bounds of an input that has been defined in the code, and we can't keep moving on with the function. And our boundary inputs, again, it's within the boundaries of that 0 and 10, and so it gives us a real answer. So next we move on to writing the actual code. And that's really easy once we've written the pseudocode because we can just convert it. So again, it's if the sphere diameter input is between 0 and 10, we get to move on and continue on with the code. However, if it's not, it automatically returns negative 999 to the user and it stops the function in its tracks. So if it is within those bounds, we get to move on. Now, to make this a little easier to read, we split up sphere diameter into radius, and we turned 4/3 into its own variable fraction. And then we use 3.14 instead of to simplify pi, because that made it a lot easier. We also used the math.power function, which made it a lot easier to get the actual cubing of the radius instead of trying to write it another way. And then we rounded it because otherwise we would have some issues with our test functions, and I'll get to that in a minute. Next, we would run our test case, and we would do that with a specific test class that we would create and run through JUnit. And I'm not going to show you that now, but we will in a couple slides. And then finally, once we had gotten that to work, we would commit and push it to the repository so that we would have it saved and our TAs and Brother Jackson could view it, and Eldon can pull it to his computer, and we would all have updated versions of the code. Okay, so next we are going to move on from this and actually show you some test functions. And I am going to give this over to Eldon, and he's going to walk you through the test matrix and playing computer before we move over to NetBeans.
Okay, can you see my screen share yet?
No, I haven't stopped sharing because remember we have to walk through this slide really quickly before.
Yeah, okay, I was gonna. Okay, so what we are looking at is one of our riddles test matrix. And as you can see, we've got our variables, our input, and our output, which is the y point. And so the valid is a 342 with it calculates to a 14. and then each of those invalid variables is returning a negative 999. And then, of course, we have our boundaries. I'm going to pause for just a second. Sarah,
Yep.
what else did I need to say here besides before we go into the code?
That was it. And now I'm going to do the screen share, and this is perfect because we can cut this bit out. Okay. And then I'm going to remember that when you do the screen share, you know how in the bottom right it'll say you and it'll say Sarah. You need to select you so that it will be broadcasting you and not me.
All right, so I'll hit screen share and full screen.
Yep, and then select over in the little right-hand corner, select your screen so that it's broadcasting you and not me.
Okay, now it looks like it's my screen there.
Yep. Or I have to do that. Sorry, there we go, because I'm the one in charge. I forgot. Okay. And then do the, and then go to NetBeans. All right, and once you're up in NetBeans, we'll start again.
Okay. And here we are in NetBeans, and what we are looking at is our test cases for a riddle. And for each test case, we see test case here. We've got these inputs, and then here's the expected result here. And then, of course, we are printing to the console right here. I see something I did wrong. No, I'm sorry. We'll cut that. Sorry, I was just looking here as I saw right here, but that's the beginning just to say, hey, this is the start of test case 2. Sorry.
All right, maybe we'll start the NetBeans bit again then.
Yeah, yes, we will. Showing our code in NetBeans, we have our riddles, the test cases for our riddles here. And so as we can see for test case 1, we've got this riddle, all the variables, the inputs, and the expected result for that. And then, and of course, we just go through and there's test case 2 and so on. And so we are going to, over here on the left on the project view, we're going to go to our riddle control test.java, which is what we are looking at. And we're going to test this file. And then we can see that it's finished. We can see that it's all tests have passed. And why does it say it has 3 tests when we have so many in there? Well, we've got 3 functions. We've got riddle 1, 2, and 3, and within one of those riddles, we have all these test cases placed. And so we've got all those test cases. We can see that everything is passed. And I think we go to you now, right, Sarah? We're going back to you now. Okay. You want to go down to a lower test case, or what do you want to do there?
Yeah, I'm just making sure that okay, so I have it selected on me now. Okay, so just like Eldon showed, I am going to go through some unit testing with you. Now, we already went through the code for this with you in our earlier part of the slide. So I am going to just show you the unit testing. It's very straightforward. So we are going to go over here to riddle control test, and as you can see, we have the input values, the expected result, and if the expected result does not match the actual result, the test will not pass. It's as simple as that. So we right-click on Riddle Control Test. We go to Test File. Once it's done testing, we open the test results window. So sorry about that. I'm going to have to restart. I hate when it does that. Okay. So like Eldon showed you before, I am going to show you how to do some unit testing for the code that we've written. Now I'm going to show you for the calculated final riddle, which is one that I wrote. And as you can see, I have put in the input values. In this case, it is 4, and the expected result for that. Now that's the one that, if you remember, we put in our test matrix, and the expected result is the one that we got when we played computer. And now we get to test that result and see if it's actually right. And if the expected result does not match the actual result, the test is going to fail, and we're going to know that there's something wrong with our code. So we go over to riddlecontroltest.java, and we right-click on it. We go over to test file, and once that pops up, we open the test results window. Now we'll see all 3 tests have passed. This is great. That means our code is working. Now, when Eldon and I first did that, that was not the case. And we could see that some of our tests had passed, but not all of them. Now, let's say when I just did this, not all the tests had passed. I could click on this arrow, and it would tell me, for instance, if this calculate final riddle had not passed, where in the code the error lay, and what line it was on, and I could click on it, and it would take me exactly to that line, and I could investigate that line of code and see where the error was and try to figure out what was going on. And that is how testing really helps you solidify your code and find any errors and make sure that what you're working with is really good, solid logic. And it says 3 tests passed because we have 3 functions. So now we are going to go, going to cut that bit out.
Lots of cutting, huh?
Yeah. Okay. So now I'm going to talk to you about variable scope and lifespan. Now, Eldon and I came up with this together. We looked through our code and tried to find an example of variable scope and lifespan that would be the most easy to understand. And we settled on calculate final riddle because it only has one variable that we really need to track, and that's sphere diameter. And what we've done is we've gone and we have enclosed the opening and closing brackets of the calculate final riddle function in a bright red box. And those opening and closing brackets are where sphere diameter lives and dies. The lifespan of sphere diameter is solely within those opening and closing brackets that are in those red boxes. However, the scope of sphere diameter is a little bit different. Now, calculate final riddle is a public function. So that means that theoretically, sphere diameter could live, or pardon me, could have a scope outside of calculate final riddle. However, for the purposes of this, sphere diameter is only ever really used within calculate final riddle. It doesn't have a use outside of it. So technically, its scope is really only within calculate final riddle. All right, I'm going to send us over to Eldon for our final slide.
Thank you. What we are going to explain right now is what we have for explaining passing by value and passing by reference. And what we wrote together, that's what we see here. It's an example of code, is passing a variable or passing a primitive is passing by value, and a primitive would be value types of integer or double or Boolean. For example, there are others, but an example that we can illustrate here is on the line that says number of gems equals 6. The 6 is a double, and that value will be passed, and we can see that it gets passed in that last line there. That value gets passed to the print to the console. Now the other type, passing by reference, that is passing the object or passing the memory location of the named value here. And what the example here would be player 1. That's the great example because we're saying the name of player 1, which is on that line where it says player1.setName. That's when you are passing that variable by reference rather than by the actual value. And that's the end of that slide there, Sarah. So.
All right, well, thank you all for listening to our presentation. I hope that this serves as a great introduction to our game, the Sphinx's Island, and I hope it helps you understand some of the concepts that we talked about, such as selection statements, function design, unit testing, variable scope and lifespan, and pass by value and reference a little bit more thoroughly. Thank you all again for having some interest in our game, and I hope you get to play it once it's finished. Again, my name is Sarah Brodakula, and my partner is Eldon Chandler. Have a good weekend.
Thank you. Bye.
Okay, so I am going to stop broadcasting